German and Japanese engines couldn't be more different in their engineering philosophy, and understanding these differences will change how you think about car ownership forever. Engineering philosophy: performance versus reliability. German engines prioritize performance and technological sophistication over simplicity, while Japanese engines focus on reliability and longevity above all else. This fundamental difference shapes every aspect of engine design and manufacturing. German engineers view engines as precision instruments that showcase advanced technology, while Japanese engineers treat engines as appliances that must work flawlessly for decades. According to Consumer Reports reliability data, Japanese engines consistently rank higher for long-term dependability, while German engines excel in performance metrics and technological innovation. German manufacturers like BMW and Mercedes invest heavily in cutting-edge technologies like variable valve timing, direct injection, and turbocharging to maximize power output. Japanese manufacturers like Toyota and Honda prioritize proven technologies that have been refined over multiple generations. This philosophical difference explains why German cars often require more maintenance but deliver superior performance, while Japanese cars need less attention but may lack the excitement factor. German engines are designed for enthusiasts who appreciate engineering complexity, while Japanese engines target consumers who want transportation without drama. The result is two completely different ownership experiences that appeal to different types of drivers with varying priorities and expectations. Materials and construction methods. German engines use premium materials like aluminum blocks, magnesium components, and exotic alloys to reduce weight and improve performance, while Japanese engines rely on proven materials like cast iron and conventional aluminum for maximum durability. German manufacturers spare no expense on materials that enhance performance characteristics. BMW and Mercedes engines feature lightweight aluminum construction with sophisticated cooling passages and reinforcement structures that optimize strength-to-weight ratios. These materials allow German engines to rev higher and produce more power per liter, but require precise manufacturing tolerances and careful maintenance. The use of exotic materials like magnesium valve, covers, and aluminum silicon alloy blocks demonstrates German commitment to weight reduction and performance optimization. Japanese engines use heavier but more durable materials that can withstand abuse and neglect. Toyota's legendary 2JZ engine uses a cast iron block that's virtually indestructible, while Honda's K-series engines employ simple aluminum construction with generous safety margins built into every component. These material choices prioritize longevity over weight savings, resulting in engines that can survive decades of use. According to automotive engineering studies, German engines typically weigh 20 to 30% less than equivalent Japanese engines, but cost 40 to 50% more to manufacture due to exotic materials and complex construction methods. This weight savings improves handling and fuel economy, but increases replacement costs when components fail. The material choices reflect each philosophy. Germans optimize for performance, while Japanese optimize for longevity and cost-effectiveness. Complexity versus simplicity. German engines embrace complexity with multiple turbochargers, variable valve timing systems, and sophisticated engine management, while Japanese engines prioritize mechanical simplicity that reduces failure points. German engineers view complexity as a path to superior performance and efficiency, implementing systems that would be considered over-engineered by Japanese standards. Modern BMW engines feature twin-scroll turbochargers, variable valve timing on both intake and exhaust cams, direct injection, and complex cooling systems with multiple thermostats. These systems work together to optimize performance across all operating conditions, but create numerous potential failure points. Mercedes engines add even more complexity with technologies like cylinder deactivation and electric turbochargers. Japanese engines achieve similar performance goals through simpler means. Honda's VTEC system uses mechanical cam switching rather than continuously variable timing, while Toyota's hybrid systems rely on proven electric motor technology rather than complex turbocharging. This approach reduces the number of components that can fail while still delivering impressive performance and efficiency. Consumer Reports data shows German engines have 60% more components than equivalent Japanese engines, leading to higher maintenance costs and more frequent repairs. However, German engines typically produce 15 to 20% more power from similar displacement due to their sophisticated systems. The complexity difference explains why German cars require specialized technicians and expensive diagnostic equipment, while Japanese cars can be serviced by any competent mechanic with basic tools. Maintenance intervals and requirements. German manufacturers recommend extended maintenance intervals of 10,000 to 15,000 miles to reduce ownership costs on paper, while Japanese manufacturers suggest conservative 5,000 to 7,500 mile intervals that actually protect engines long-term. This difference reflects completely different approaches to engine longevity and customer expectations. BMW and Mercedes' extended oil change intervals are designed to minimize maintenance costs during warranty periods, but can cause long-term engine damage. German engines run extremely hot with tight tolerances that break down oil faster than manufacturers admit, leading to sludge formation and premature wear. These extended intervals look attractive to buyers, but create problems after warranty expiration. Japanese manufacturers like Toyota and Honda recommend frequent oil changes because they understand that regular maintenance is cheaper than engine replacement. Their conservative intervals account for real-world driving conditions rather than ideal laboratory scenarios. This approach may seem more expensive initially, but saves money over the engine's lifetime. According to independent automotive research, German cars following manufacturer maintenance schedules require major engine repairs 40% more frequently than Japanese cars following their recommended intervals. German cars maintained with 5,000-mile oil changes show dramatically improved longevity, proving that manufacturer recommendations prioritize warranty costs over long-term reliability. The maintenance philosophy difference explains why German cars have higher long-term ownership costs, despite similar initial purchase prices compared to Japanese alternatives. Turbocharging approaches. German manufacturers adopted turbocharging early and aggressively to maximize power from smaller engines, while Japanese companies remained conservative with forced induction until recently. German turbo systems prioritize performance over longevity, using aggressive boost levels and complex systems that push engineering boundaries. BMW pioneered twin-turbo systems in the 1980s and continues pushing turbocharging boundaries with technologies like electric turbochargers and variable geometry systems. Mercedes uses sophisticated twin-scroll turbos and complex intercooling systems to maximize power output from small displacement engines. These systems deliver impressive performance but require premium fuel and meticulous maintenance. Japanese manufacturers like Toyota and Honda avoided turbocharging for decades, preferring naturally aspirated engines with proven reliability. When they finally adopted forced induction, they used conservative boost levels and robust components designed for 200,000-plus mile service life. Their turbo systems prioritize durability over maximum power output. Consumer Reports reliability data shows German turbocharged engines have failure rates 3 times higher than Japanese naturally aspirated engines, but produce 30 to 40% more power from similar displacement. German turbo systems require premium fuel and frequent maintenance to prevent catastrophic failure, while Japanese turbo systems are designed to operate reliably on regular fuel with standard maintenance. The turbocharging difference reflects fundamental priorities. Germans accept reliability risks for performance gains, while Japanese prioritize longevity over maximum power output. Fuel system design. German engines use high-pressure direct injection systems that maximize power and efficiency, but create maintenance challenges, while Japanese engines employ simpler port injection or dual injection systems that prioritize reliability. German fuel systems operate at pressures exceeding 2,000 psi compared to 60 psi for Japanese port injection systems. BMW and Mercedes direct injection systems spray fuel directly into combustion chambers at precisely timed intervals, allowing advanced combustion strategies and higher compression ratios. These systems improve power and fuel economy, but cause carbon buildup on intake valves and require expensive high-pressure fuel pump replacements. The complexity of these systems demands specialized diagnostic equipment and trained technicians. Japanese manufacturers like Toyota use port injection or combine direct and port injection to get benefits of both systems while maintaining reliability. Port injection cleans intake valves naturally and operates at lower pressures that reduce component stress and failure rates. This approach sacrifices some performance potential for long-term dependability. According to automotive service data, German direct injection systems require carbon cleaning every 40,000 to 60,000 miles at costs exceeding $600, while Japanese port injection systems rarely need fuel system maintenance beyond filter changes. German high-pressure fuel pumps fail frequently around 100,000 miles, requiring expensive replacements. The fuel system difference explains why German cars have higher maintenance costs and more frequent fuel-related problems compared to Japanese alternatives. Cooling system philosophy. German engines use complex cooling systems with multiple thermostats, electric water pumps, and sophisticated temperature management, while Japanese engines rely on simple, robust cooling systems that prioritize reliability over optimization. German cooling systems are designed for maximum efficiency under all conditions, using advanced technologies to maintain precise operating temperatures. BMW engines feature multiple cooling circuits with separate thermostats for the engine block and cylinder head, allowing precise temperature control for optimal performance and emissions. Mercedes uses electric water pumps that can operate independently of engine speed for better cooling control. These systems optimize engine temperature for performance and efficiency, but create multiple failure points. Japanese engines use simple cooling systems with mechanical water pumps, single thermostats, and generous cooling capacity margins. Toyota and Honda design cooling systems that can handle extreme conditions without complex electronic controls or multiple failure points. This approach prioritizes reliability over optimization, ensuring consistent operation under all conditions. Consumer Reports data shows German cooling systems fail 4 times more frequently than Japanese systems due to their complexity. But German engines run at more precise temperatures for better performance and fuel economy. German cooling system repairs typically cost $1,500 to $3,000, compared to $300 to $800 for Japanese systems. The cooling system difference reflects German optimization for performance versus Japanese optimization for reliability and serviceability. Electronic integration. German engines are heavily integrated with complex electronic systems that control every aspect of operation, while Japanese engines use simpler electronics focused on essential functions. German engine management systems can have over 100 sensors compared to 20 to 30 in Japanese engines, creating vastly different diagnostic and repair experiences. BMW and Mercedes engines feature sophisticated engine management systems that continuously adjust timing, fuel delivery, turbo boost, and valve timing based on dozens of sensor inputs. These systems optimize performance and emissions, but create diagnostic challenges when problems occur. The electronic integration extends to every engine function, from cooling fan operation to oil pump control. Japanese engines use simpler electronic systems that focus on reliability rather than optimization. Honda and Toyota engine computers use fewer sensors and more conservative programming that prioritizes consistent operation over maximum performance. This approach reduces the complexity of diagnosis and repair while maintaining excellent drivability. According to automotive repair data, German engine electronics account for 40% of all engine-related problems, while Japanese engine electronics cause less than 15% of issues. German electronic repairs require expensive dealer diagnostic equipment and specialized training, while Japanese systems can be diagnosed with basic scan tools available to any mechanic. The electronic integration difference explains why German cars need specialized technicians and why Japanese cars can be serviced by independent mechanics with standard equipment. Manufacturing tolerances. German engines are built to extremely tight tolerances that optimize performance but require precise maintenance, while Japanese engines use looser tolerances that accommodate wear and neglect. German manufacturing precision comes at the cost of maintenance sensitivity, creating engines that reward proper care but punish neglect. BMW and Mercedes engines have tolerances measured in thousandths of an inch, allowing optimal performance but requiring exact oil specifications and frequent changes. These tight tolerances maximize power output and efficiency, but create sensitivity to contamination and wear. The precision manufacturing enables higher performance, but demands corresponding precision in maintenance. Japanese engines use more generous tolerances that allow components to wear without immediate performance loss. Toyota and Honda design engines that maintain acceptable performance even when maintenance is deferred or incorrect fluids are used. This approach sacrifices some performance potential for real-world durability and forgiveness. Engineering studies show German engines lose performance rapidly when maintenance is neglected, while Japanese engines maintain consistent operation despite abuse. German engines require premium oils and exact specifications, while Japanese engines tolerate conventional oils and longer change intervals. The tolerance difference explains why German engines reward meticulous maintenance but punish neglect, while Japanese engines forgive owner mistakes and continue operating reliably. Design lifespan expectations. German engines are designed for 150,000 to 200,000 miles of enthusiastic driving with proper maintenance, while Japanese engines target 300,000 plus miles of reliable transportation with minimal attention. This fundamental difference shapes every design decision and component choice, creating engines optimized for different ownership experiences. German manufacturers design engines for performance-oriented owners who appreciate sophisticated technology and don't mind higher maintenance costs. BMW and Mercedes engines are engineered to deliver maximum performance during their intended lifespan, rather than maximize longevity. This approach creates exciting driving experiences but requires committed ownership. Japanese manufacturers design engines for mainstream consumers who want reliable transportation without drama. Toyota and Honda engines are over-engineered for their power output to ensure decades of trouble-free operation with basic maintenance. This philosophy creates engines that may lack excitement but deliver unmatched dependability. Consumer reports. Long-term reliability studies show Japanese engines routinely exceed 300,000 miles with original major components, while German engines typically need significant repairs or replacement between 150,000 to 200,000 miles. However, German engines provide superior performance and driving excitement during their service life. The lifespan difference reflects completely different target customers and use cases. Germans build engines for driving enthusiasts, while Japanese build engines for practical transportation needs. There you have it, the fundamental differences between German and Japanese engine philosophy that explain why these power plants behave so differently. German engines prioritize performance, technology, and driving excitement, while Japanese engines focus on reliability, simplicity, and long-term value. Understanding these differences helps you choose the right engine for your needs and expectations. If you want cutting-edge technology, maximum performance, and don't mind higher maintenance costs, German engines deliver unmatched sophistication. If you prioritize reliability, low maintenance costs, and long-term durability, Japanese engines provide unbeatable value. Neither approach is inherently better. They serve different purposes and appeal to different types of drivers. German engines reward enthusiasts who appreciate engineering excellence and accept the costs of complexity. Japanese engines satisfy practical buyers who want dependable transportation without surprises. The key is matching your expectations with the engine philosophy. Don't expect German reliability from a performance-focused engine, and don't expect Japanese excitement from a reliability-focused design. Choose the philosophy that matches your priorities and enjoy the benefits of each approach. If you enjoyed this video, hit that like button and don't forget to subscribe for more content like this. I will see you in the next one.